My name is Sam Carlton. I'm a web consultant. I'm a serial software entrepreneur and advisory consultant for software-related issues. I've been building software and advising on software for 10 years, and I built, as far as like, you have to do bragging rights, so as far as bragging rights go, I built the largest online community for Apple Silicon software compatibility info. You have to like qualify specifically, but that's my bragging rights. So we're going to go through. We're going to have 3 parts to this, and then we're going to have questions, and then we'll take a moment between each part to answer any questions you guys might have thought of randomly on that. So out of you guys, how many of you currently have a software product that your company owns or was working on? Oh, cool. Cool. And then how many of you plan on building a software product for your company or just any kind of software product in the future? Perry? Okay, cool. And then how many of you know what technical debt is or have heard the term? Perry? Okay, cool. And then how many of you guys have software engineers on the team or at your company? Okay, cool. So this is pretty good. This is actually I figured there would have been like more people knowing about technical debt, but this is actually really great because this is a new thing that I get to share with you guys. And I've shared this concept with people before in other industries, and they're like, "Wow, that totally." I don't even write software. We don't even do anything with software, and that totally applies to our company. So, what is technical debt? So, technical debt is the cost of building fast and making too many compromises along the way. So, there's when you're building your software product, whether it's with code or no code or whatever you're doing, whether if it's like a WordPress thing, when you make compromises, when you build too fast and low quality, those choices build up over time and end up in a large payment that you have to pay at some point. That payment comes in the form of opportunity, or you just have to spend time reworking that product. Sometimes you have to start from scratch because your product isn't, like an example could be you're building a video game and the orders from management are, well, we're going to build a single player video game, so you build all your things around that, and then they're like, actually we want multiple players. So that changes the whole product almost to the point where you have to start from scratch. That's technical debt. So part of it is when your requirements change that you're going to deliver on, or there's a requirement that was never mentioned, that was never lined out. So another thing is like with all the well-established software houses in the world, if you guys are going to be competing with companies like Google and Facebook, in an area where they're weak in and you want to capitalize on what they're not paying attention to, you have to understand how to manage your technical debt, because starting out, you have 0 technical debt. And your advantage literally over Google or Facebook or Microsoft or whoever is that they have technical debt because they have products that have aged and have done certain things. So you can outmaneuver them until you get about a certain size, and then at that point you have to you have to deal with your own technical debt. So if you start out early and manage it in small ways and do very small things and certain habits, you can get out ahead of it and keep your company and your product agile. No matter what, technical debt must always be paid. Like it's going to have to be paid up front or at a time when the technical debt chooses for you. And that's usually at a very inopportune time, such as like a product launch, or you really need to get a certain feature out and it's costing you hundreds of thousands, maybe millions of dollars, but you have to wait 6 months to refactor the product and rebuild things because you have technical debt that has to be paid. You don't get to choose to go any further. You have to wait. And then other people who are your competitors or larger products get to go ahead because they're new or they've paid their technical debt. Now, not all technical debt is bad. To build anything, to do any kind of software product, you have to accrue technical debt. It's going to happen no matter what. It's unavoidable. So the key is managing the technical debt. So it works a little bit like this. You start out, you have your product, you have no debt, you don't really have to pay off like all the things and put things together. But as your product grows and you don't maintain your quality of features and the quality of product build, it gets more and more difficult to expand and to grow into the features you want to do and deliver the requests that clients want and customers want to have from your company. But the difference is you have this slower start, and it takes longer at the beginning, but that pays off down the line when it's 2 or 3 years past, and you get that high velocity where you have all this flexibility, you have all your test suite set up, and all your automation going, where you have the confidence to know, oh yeah, we can go right into this feature, and it's going to be fine. We have all these checks and balances in place. We've paid the technical debt. We don't have to like question whether or not we're ready for this. So go into the next. So there's also a cost outside of just frustration with technical debt. There's some very real like business related costs. One is like Zoom's outage. Now Zoom has done all right in this past year, but they actually should have been probably 50% larger than they are because of the outages they've had. So they missed some of that opportunity, and then Google and some other companies came in and scooped up some of their market share because Zoom had technical debt and their product wasn't ready to scale. It wasn't ready for a global pandemic. It wasn't ready to grow that fast. And to be honest, it was probably not ready to scale however fast they wanted to scale already. Another one is MySpace. So some of you guys have heard of that. So MySpace, they built on a stack that was kind of like a monolithic app, is not very flexible, it's kind of like a thing where one software engineer knows about all the things and you have to go to them. And what happened to MySpace? Well, Facebook came around, and Facebook manages their technical debt well, and so they surpassed MySpace. MySpace tried to keep up and add features, and you can even tell like the new MySpace where it's like all about music or something. It's like they've kind of tried to go that way, but it's not there. It's like now it's just kind of one of those half-dead startups or tech companies, and maybe they'll come back around eventually, but effectively they're nowhere near as big as Facebook. And they could have been all of what Facebook is, but they couldn't grow. They couldn't keep up with the feature set. So another more recent one is a game called Cyberpunk, and this is a big failure. This is probably one of the largest failures as far as a technical software product has happened in recent memory. So they spent 10 years developing this CD Projekt Red, the software house. They've historically built very popular titles that have been received well, and so there was a lot of excitement for this title. And they spent 10 years developing it, but there was all this kind of pushing from the exterior to just like, hey, go ahead and ship it, go ahead and launch it. And it's hard to say what happened internally. Probably it was an investor pushing for them to go ahead and launch it, and they went ahead and launched it in 2020, and it ended up being the worst video game launch as far as like over $100 million in history. One of their investors went back to sue them. Another thing is, what was this article? Yeah, it was basically just the biggest failure for a video game. And the harder part is like they spent 10 years on it. They weren't speeding through it. Like there's other software titles that could be developed in 3 to 4 years. They were trying to take their time, but it just wasn't there yet. It wasn't fully baked, and they ended up paying for that by kind of tarnishing their name for a while, and it's going to take them a while to get that back. And that costs them easily hundreds of millions of dollars. So that is the real impact of what technical debt can do on a business. So when you go to your CEO or your management, and they're like, what's the benefit of this? It's like, it's millions of dollars. So where's the advantage? So you guys all came here. You were the title was something about the unfair advantage in managing technical debt. So you don't want to hear me like talk negative and like tell you about how bad it is. So the fun part is companies that manage technical debt well, they get advantages over companies that are either not managing it or just ignoring their technical debt. One of those, like I already mentioned, is Google Meet. Zoom kind of fell behind on their product, and so Google came in and scooped it up and built I would argue, easier to use product Another one is Facebook created HHVM, which they were running into their own limitations on their programming language PHP, because it was kind of open source public approval process for them to add new features into it. So Facebook just made up their own programming language that worked better because they had properly managed their technical debt. And it ended up, the PHP organization actually took Facebook's updates and integrated it into they just skipped a version and integrated it into the main programming language for everybody to use. And now everybody uses it, if your app runs on PHP. Another one, again, a Facebook example, is they create React to overcome the limitations of current front-end frameworks. And it was really kind of a pivot shift on how front-end is built and a different philosophy. But they had the time, they gave themselves the time to build that product and really get into the details of how that could work. And they weren't rushing on anything. And when you have a healthy environment for software engineering, this is what can come out of it. Now there's all kinds of companies. Airbnb is if you use any of their products, they're all built on Facebook's React framework. Even though Facebook owns none of Airbnb, all these other companies are now benefiting from Facebook's proper technical debt management. So managing technical debt keeps your product flexible. The other benefits, it reduces outages. If there's an outage and you have to figure out how to navigate that, it can shorten that time. There's always going to be issues that come up, but it can help with that and reduce the conflict with that. More agility with competitors. We already talked about that. More confidence to try new and different things, and that comes with test-driven development. And you get to focus more on innovating. Do we have any questions so far about like technical debt and managing and anything like that? Okay. Oh yeah.
Well, I had a question. Maybe wait, but it's an example. I was curious.
An example?
Yeah.
An example, like a bad example or a good example?
Just curious. I'll ask a question. Maybe you can address later if it's too soon. But I'm curious about the Bitcoin code base and technical debt as it relates to something like Ethereum or newer blockchains, where it seems like their technical debt, or if it is applies, it seems like it's an advantage for that currency's growth because it's more stable or more. The changes in the code are perceived to be what could make it less, viable, I guess, if I understand it correctly. I don't know if you have
Sure.
thoughts on that.
Sure.
That relates to
There is a lot of value in stability.
Yeah.
That's why like you have older frameworks like .NET and those enterprise frameworks that don't change as much. So larger companies that need slower change. That's why those companies are hesitant to adopt newer technologies, because they're all their engineers are like, well, we should try like serverless and like Node and all these cool, hipster coding things like so. But they can't. They don't know the implications, and like if it changes, it's like, what was it? Like I use a framework called Gatsby for different sites, and they just announced that they're abandoning Node 14 or Node 12 or something, so like a 4 or 5 year old technology. And so there is value in that. It's not necessarily that it has technical debt, it's that it doesn't change a lot. Mm-hmm. And probably most of the technical debt has been paid. So technical debt comes usually from changing the code. So if it's already a pretty stable product, then every time you change it, you might create some of that technical debt, or if there's things up the pipeline that change that it depends on, that can create that technical debt. Does that answer that question? Okay. Yeah.
I was just wondering if you had any thoughts on kind of changing the requirements of managing technical debt when it comes to like software versioning. Mm-hmm. Because if you're just putting out like an alpha or a beta mostly like an alpha just to test like the market to see if like users or customers are even interested in your product, like should you be as concerned of like, oh well, we'll just put this little band-aid here because we're just seeing if this thing has legs underneath it, because maybe you might just scrap it totally if you decide to continue, or you're just want an easy out if, let's say, like your product isn't needed by the market. Like, is it necessary to have the same kind of attention to technical debt, like through each kind of like stage of like software versioning, or?
Yeah, there's in video games when they're developing a product like a new IP or game mechanic, they'll develop it completely in isolation from the core product, and then when they start actually building it, they'll get rid of all their code and they'll start from scratch. There's actually have you guys heard of the story of Moby Dick? Have you heard of the story of how Moby Dick was written? So I forget the guy's name, the author, Herman Melville. He finished the book, a book as thick as the Bible. I mean, it's like, I don't know if you guys have written any books like that thick, but it's he finished the manuscript, and back then it wasn't like Google Docs where it's backed up. It's like, it's a manuscript, that's the book. You send it to get published, and then there's, it goes out. And he got out in an argument with his wife about, probably because he was spending all his time writing this book as thick as the Bible. And his wife took the manuscript and threw it in the fireplace, and it burned up and completely destroyed it. 300 or 400 pages, whatever it is. He had to write all of Moby Dick from scratch. But if you think about it, if he had published that original manuscript, would it be Moby Dick? Would it be the version of Moby Dick that became popular that we know? Because that undoubtedly, that first version was way different. But he was forced to go through it from beginning to end and redo it. So there is value, to your point, there is value in like going through and giving yourself kind of like, this is a throwaway build. We're not going to keep any of this. This is just kind of like playing around and experimenting. So we can create as much technical debt as we want, because we all agree at the end we're going to throw this out and start from scratch. We're gonna Moby Dick it.
And is that a kind of a good strategy when developing and like testing new features of a product, where it's like, this, not like the entire product build is a throwaway, but like this one specific part, let's say like you're testing like a way to like pin messages on the interface, like it doesn't have to be as clean, or whatever we're just seeing. So okay.
Yeah, you could fork it from the main branch and just never. This is a throwaway fork. We're gonna, and that's assuming you have version control. You always want to use version control as much as possible. But yeah, you can apply that, and that's just one concept. There's other ways to approach it and deal with it. Next slide. So recognizing technical debt. So the advantage of recognizing technical debt is that you can see when your competitors are kind of asleep at the wheel and they're not really paying attention. And so some of the ways is you see frequent confusion and frustration from users. Every product is like this, but you can pinpoint the weak areas as far as where technical debt needs to be paid based on the feedback you're seeing from their users or you're seeing from your users. Product skims on the small details. This is just like when you're using the product for a while and you start to notice kind of like they're not paying attention to really deep like user appreciation, and it's usually in UI issues. Sometimes it's in like critical app functionality that would come from the server or the mothership, whatever. And then the product has areas that need TLC or updating. There's just kind of like, you go to a view or in the app or the website, and you can tell it's like from 3 or 4 versions back. They've just kind of like let it like sit, and they haven't bothered to touch it because they don't want to risk creating new technical debt, and they don't want to pay off their technical debt. So is there any more questions about that? Just like the advantage and mitigating. Cool. So the next part is managing technical debt and keeping that balance. So the first thing I'm going to push on is the code quality. This is what's called the ground game in UFC. Now, I'm not going to pretend I'm a UFC like person. I just love the idea of ground game. And so what I heard this in a presentation, so I'm going to steal it. So ground game is the thing that you do that nobody else likes to do. So, and what that is kind of for software products. That is things like version control, things like continuous delivery or continuous integration, things like test-driven development. And like even software engineers don't really love doing all this stuff, but it is the ground game. It is the thing that if you do it, and if you pay off that ground game and you work on that, it will give you an advantage later on, because nobody else is doing it. So now you have that leverage. Another version of continuous delivery is continuous integration. So continuous delivery is just it's one of the most effective tools against technical debt, and it's basically there's kind of several layers. There's continuous integration where you're always testing things on the code automatically every day or every time there's any kind of change made to the product. And then continuous delivery is you actually test it and build it as if it's going to ship all the way up until release. And then you let it go as close as it can get to release without actually going to actual customers. And then you have checks on that final version. And then continuous deployment is where it goes all the way through. It goes, like, you make a change and it goes all the way to users. And so continuous delivery is kind of the balance between the two. If you're not super extreme where you want to ship out like changes to users, then you can do continuous delivery. And usually cowboy coding, where you're editing the code directly, there's no version control, that amounts to effectively continuous deployment in a way. But it's just super dangerous. Another one is code linting, and using your code linters to just kind of keep a consistent style across your code. And I know this gets into like some of the technical side, but this is the part that has to be it's the most crucial part to affecting and preventing the technical debt. Fewer arguments and functions, and smaller code blocks. Just keeping your functionality and the code that you write in smaller pieces. So getting into the less technical side of how to manage technical debt, keeping a public ongoing list of the technical debt that you're aware of. So every time somebody thinks of something, it could be like a Kanban board on Trello, or it can be like a physical like board that you guys have, and you write down the features like, okay, we have some technical debt in this area that we need to pay off. And that way everybody's aware of it. And so every time if there's an issue that comes up because of that technical debt that has yet to be paid, you can move it up higher on the list. And it's like why did that break? It's like because we haven't paid the technical debt. We haven't rewritten the button logic or whatever it is. And another way is reserve time for payment. So that's instead of immediately starting on a new feature after you finish, after you release one to the public, figure out how long it took you to build to get to that point on that feature, and take 20% of that time and reserve that for paying off technical debt, either on the feature you just did or on other features. And that's just kind of building that into your timelines for your projects. And when you're introducing new features in your software, helps keep that technical debt well managed. Or you'll just, maybe you've been managing it well, and you'll just take that time to have a pizza party or something, I don't know. And then the last thing is look to break things early. And so this kind of goes against what companies like to do is, and this applies with continuous delivery, is the reason you want that continuous delivery is because you want things to break from what you can see from the back end, from the development, before the users see it, as opposed to just kind of like shipping it out and be like, if it doesn't work for somebody, they'll let us know, which sometimes they do, sometimes they don't. Sometimes they just get frustrated and go to another product. And that got kind of leaning into like, no, I want to know every way this can break, and if it hasn't been breaking, I want to find out another way it can break. Like, let's start like going crazy. Like, what happens if somebody uses this and their mouse just doesn't work? Like, can they do this with their keyboard? Can they do this with just the mouse and no keyboard? Exploring different areas like that of like, okay, how do we figure out where this can break, and how do we find those flaws and pull them out, as opposed to kind of avoiding them and crossing our fingers and hoping they won't show up. And that is the third part. So that's the presentation. Do you guys have any? So next is just this part is just for questions. We can take all the time we need.